Hello, good morning to one and all. I am audible to all.
Yes,
Yes,
sir.
sir.
Okay. There is today the network issue, but we will start. Just I am sharing my screen. As already we have started with that particular transition metal, the chemistry of the transition metal. PPT is visible.
Yes, sir.
Okay. We have to talk about the chemistry of the transition metal. In that, we have studied already in the class, physical class position of this particular transition element, periodic table. Then we have talk about the natural occurrence of this particular elements and their minerals. We have seen the little bit example. Then we have talk about the significant special stability of D0, D5, D10 leading to the variable oxidation state. Variable oxidation state we have seen. Unusual oxidation state and their stabilities in the aqueous solution with special reference to the vanadium and chromium. Origin of the color of the transition metal and their compounds that we have to see. Then magnetic property and then chemistry of the titanium and vanadium, its properties of the oxides and the chlorides, and use of this in the triatomic analysis. And then we have to talk about the qualitative test for the transition metal ions, general consideration in devising the test with reference to the chromium, manganese, iron, cobalt, nickel, and copper. That we will see one by one. Now, the one of the most popular reason why they are metal is that the transition metal is a variable oxidation state. They possess the different color. Now, why the different colors are there? No, these transition metals, their complexes or they have the different color. Why? There are so many factors which are responsible for their particular colors. Now, usually only metals with the D0 or D10 form the colorless compound. Means the zinc and the silver, you can see the for this compound because they have the no d electron. Means you can conclude that these are the questions what we have to ask. Now, colors in the metal complex or any compound is it is very true that I said whatever we reflection means see for example for the green the leaves are there, plants are there, and generally the leaf of that plant is in the green color is there. That leaf absorb the red light from the UV visible spectrum, means that particular whatever the light is available in the surrounding, and they are emitting the green light that we will see in that particular topic. So many factors are there. We have to see the reflectivity, that one is there, surface coating, packing density for the metals and the nature of the d orbitals, number of electrons in the d orbital, geometry, ability for the charge transfer. Here we have seen for the zinc and that silver, D0 and D10 configuration is there. At that time, they are in the colorless. Means the number of electrons in the d orbital matters the color for this particular transition metal. That transfer geometry also matter for this particular. Please tell me this video is visible or not.
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Once again, welcome to Bholanath Academy. Today we are going to see the color transition. Why we are getting the color transition? So students, first question is rising in our mind. What is DD transition? If you know the DD transition, you can understand the color of the transition compound. Because transition element contains d orbitals. Because of d orbitals, students, they are orbitals that we are going to see. Before that, the question is arising in our mind. What is DD transition of electrons? Now, students, DD transition is happening in the mode. One or more electron from a lower to higher energy level within that is called as DD transition. In compound, 5 d orbitals split into two groups, that is easy and T2G orbitals. Now what happens, students, when you see the d block elements, students, there is a 5 d orbitals are there. Now when the light will fall, it will split into two orbitals, that is easy and T2G orbitals. EG orbitals is containing 2d orbitals and T2G orbital is containing 3d orbitals. That means 5 degenerate orbitals. They are coming into what? Two different energy level. This is the level of the energy. This is first level and lower layer, and this is what? Higher energy level. The lower layer and this is higher. You can say this is lower and this is what? Higher energy level. When the light will fall, students, the electron which are present in lower orbitals, they will transit to the T2G or easy orbitals. This is called as transition, BD transition. This is the about the digit that we call also called as splitting of d orbitals. Now, students, complementary color can be easily identified with the help of this. I have shown the star. Now, students, this is the star. This is star, students. What happens, students, when the complex observe the green light? We can see red in color. The compound will, if the compound is observing green color, that means we can see the compound color is what? Red. That means the compound transmit red color. That we can see the compound is red in color. If it is violet, the compound is observing violet color, we can say it is yellow. If compound is observing yellow color, that means it will transmit violet color. If I observe blue color, it will give you orange. If it is observe orange color, it will transmit blue color. This is the Vibgor. Vibgor is, students, very famous school name. You know, with the help of this, you can write the all the colors, 7 colors, no, with the help of Vibgor. Vibgor is the name of the school. So this way we can also learn these complementary colors. Now, students, you know the leaf, which are why they are green in color, because the leaf are observing red color light. So the color of the leaf, because we are dealing with the compound, complex compound here, titanium, hexaco 3 plus, titanium is less 1 electron. Electronic configuration, it is written here, students. So what happens, students? The complex observe green, yellow light and transmit red, blue light. Red, blue is also called as purple color. Now, students, this compound, it looks purple in color. Why this compound is purple in color? Because this in compound, when you see in the compound, there is a titanium is present 3 plus cations. That means it has, the compound has 3d1 orbitals. 1 electrons are present. This 1 electron is observed green, yellow light, and the electron will go to the higher energy level. That is, it will transmit red, blue light. When the electron jump from higher level to lower, it will emit red, blue color. So we can see the compound is it looks red, blue in color. That is purple color. Now, students, with the help of the diagram, we have shown this is the titanium 3 plus containing 3d1 electrons. What happens, students, when it observe light, green light, it will transmit when the electron will jump from lower energy orbitals to higher energy orbitals. After some
क्या
time, what, students,
प्रॉब्लम
this
मगर
electron will come
हमेशा
back. While coming back, students, it will emit the light that is red in color. That means we can see the compound looks what? Reddish in color, that we call as
नंबर
purple
को
color.
रिस्टार्ट
So
करके
purple
देखने
color
बोलना
of this compound explained with the help of this diagram. So this is also called as DD splitting of the. It's very easy to explain the compound titanium hexaco 3 plus. So this way we have explained the why is what? Purple in color, that means red in color, red. So this way we can explain the with the help of the because of the DD transition. Yeah, we can see splitting of the d orbitals into T2G. This is easy orbitals, and this is what? T2G orbitals. So these two groups are these 5 d orbitals are split in two parts, easy and T2G orbitals. And because of the this transition and transmission, this compound is what we are getting purple in color. The compound, why it is purple in color, with the help of this diagram we have explained. Thank you very much, students. If you like my video, please share it, subscribe it. Thank you very much.
Okay, one of the example that we have seen that DD transition is very much responsible for the color to the transition element. What you understood that particular DD transition, how it takes place? Yeah, you can say. You got that?
Yes, sir.
Okay, what is DD transition? In the d whatever the we are talking about the d orbitals, they have the 5 suborbitals. Okay, 1 2 3 4 5. Okay, in that 5 orbitals they become separated according to their energy. Okay, according to their level of the absorption of the energy. 3 orbitals of the d, the 3 suborbitals of the d come together and they gives you the T2G. They are also called as a triply degenerate orbitals. And two orbitals having the same energy, they goes to the higher energy level and form the EG, and that are called as a doubly degenerate. Why doubly degenerate and triply degenerate? Because there are the two orbitals, and in the lower one there are the three orbitals. That's why they are the name as the doubly and the triply. Okay, but triply degenerate orbitals are having the lower energy as compared to the doubly degenerate orbitals, and this is a very much important factor which is for their the color to the transition elements, or you can say the color to the transition compounds. As you seen that complex, whatever you will prepare in the lab, that complex have the innocent and a very beautiful color. This is due to the DD transition. Okay, we'll stop here. If you have any doubt, any difficulty, you can ask.